Hello, everybody. Today I'm going to teach you how to multiply two linear binomials. All right, so a binomial, first of all, is an expression with two terms. For example, a linear function is in slope-intercept form is binomial. It's binomial because it contains two parts, hence binomial. These two parts are, well, the x and the b. All right, and so let's see what happens when we multiply these binomials. All right, so the big idea here is that when you multiply these two binomials, what's going to result is a quadratic. So a good thing to keep in mind is that linear times linear equals quadratic. If you take two linear functions and multiply them, the result should be a quadratic function. Let's try it out. So here's an example. We have the function f of x equals 3x plus 1 multiplied by x plus 2. All right, so that looks like a linear function, 3x plus 1, and another linear function, x plus 2. All right, now watch what happens when I graph it. All right, when I graph it, you can see that 3x plus 1 times x plus 2 is actually a parabola. All right, it's a parabola, which means it's quadratic. So let's talk a little bit more about how to actually multiply these two factors. All right. Well, the first way that I'm going to show you is distributive property, right? So you can think I'm going to multiply this 3x by this x. Well, the result of 3x times x is 3x squared. All right. And now I have two terms in each factor. So I also need to multiply this 3x by this 2. So 3x times 2 is 6x. All right. Next, I'm going to multiply 1 by the x. So 1 times x is 1x. So I'm going to add 1x. And then last, I'm going to multiply 1 by 2. So 1 times 2 is 2. All right. So now I can see a quadratic component. See, as soon as I multiplied 3x times x, I got 3x squared. All right. Because x times x is x squared. So the last thing I'm going to do is combine my like terms. So this results in the graph of 3x squared plus 7x plus 2. Now that looks a little bit more like ax squared plus bx plus c, which is the form for quadratics. All right. So that's how we took two linear factors and multiplied them to get a quadratic. Now, I'm going to show you one other way of multiplying these, and this is actually a really useful tool. And we call this the box method. All right, this helps you visualize a little bit more. All right, so I'm going to write my two linear factors, 3x plus 1. The 3x is a term, and the 1 is another term. And then I'm going to write x and plus 2. Those are my two terms from the second factor. And I'm going to visualize the multiplication now as row times column. So x times 3x will give me a result of 3x squared. X times 1 gives me 1x. So hopefully this helps you visualize better. 3x times 2 is 6x. And 2 times 1 is 2. Remember that you are multiplying right here. The next thing is your like terms. If you do this way in this order, your like terms are going to be found at a diagonal of one another. So the final quadratic is 3x squared plus 7x plus 2. That is called the box method. The box method. Okay. And we can try one last example. All right. So one more example. We'll cut this graph off, but you could see that every time that I simplified it, I got the same graph. All right. So here is, for example, g of x. G of x equals x minus 1 times x plus 4. All right. So I'm going to set up my box. Okay. Here we go. Whoop. X minus 1 and x plus 4. All right, x times x, x squared. X times negative 1, negative 1x, or just negative x. And 4 times x, 4x. 4 times negative 1, negative 4. Final result, x squared, like terms, 4x and negative x. So 4x minus x is 3x. X squared plus 3x minus 4, all right, which you can see that I used as, I can see every step of the way right here, that is the correct function, x squared minus 3x plus 4. I now have my a value of 1, my b value of 3, and my c value of negative 4. That's multiplication.